Good afternoon, this is Mr. Morales. Today we're going to talk about completing the square, another way to solve quadratics. So our first two examples were asked to solve the equations below by factoring and using the square root property. So what we have here is an equation that equals, it's a quadratic equation that equals 4. So let's go ahead and factor it first. So we have x times x will give us the x squared. I need two numbers that'll multiply to give me a positive 49 and add to give me a positive 14. And those two numbers would be positive 7. So what I have is x plus 7 times x plus 7 equals 4. This is what we call a perfect square trinomial. We have three pieces of a quadratic equation that is made up of the same factor being multiplied times itself twice. So we have x plus 7 squared equals 4 because we have two x plus 7s. Or we have x plus 7 being multiplied times itself, which means squared. Now I can solve this pretty easy. What I'm going to do now is I need to get x all by itself. So I'm going to square root the left side and the right side. And when I do that, I then get rid of the squared and I'm left with just x plus 7 equals the square root of 4, which is going to be plus positive 2 and negative 2. Because remember, when you take the square root of a positive number, you have two possible solutions. So now I have to do two equations. I'm going to solve one equation where x plus 7 equals the positive 2 that I have here. Then I'm going to do another equation where I have x plus 7 equals the negative 2 that I have down here. For both of them, all I do is subtract 7 from both sides. When I do that, I get x equals 2 minus 7, which is negative 5. Now on this side, I get x equals negative 2 minus 7 more, which is negative 9. So my solutions are at when x equals negative 5 and negative 9. These would be the two spots on the x-axis where my quadratic equation intercepts the x-axis. Now to practice this again, let's go ahead and I'll begin first by factoring the equation. I know that I'm going to have x and x. Two numbers that multiply to give me a positive 9, but add to give me a negative 6, and that would be negative 3. Negative times negative 3 equals positive 9. Negative 3 plus negative 3 equals positive 6. Now that I have those, I basically can write it as a perfect square. What I have is x minus 3 times itself equals 20. And just like in the last example, I'll solve for x by getting rid of the squaring by square rooting. When I square root a square, it cancels out, and I'm left with whatever's underneath the radical sign, x minus 3. However, the square root of 20, I need to break up. The square root of 20 is the same thing as the square root of 4 times the square root of 5. The square root of 4 is basically going to be, well not basically, is 2 plus or minus 2 times the square root of 5. Now I have to go ahead, and what I'm going to do is, square root of 5 is going to be a decimal, so it doesn't matter what I multiply it by, I'm going to always have a decimal answer. So what I'm going to do is I'm going to shorten this equation a little bit. I'm going to say, I'm going to add 3 here to this side and to this side. So what I get is x equals 3 plus or minus 2 square roots of 5. I could say 3 plus 2 square roots of 5, that's my first answer, some random decimal, and 3 minus 2 square roots of 5. I'm going to keep it in the radical form like this whenever I have long, complicated decimals. But if I'm ever able to get whole number answers like I have over here in the first example, then I'll go ahead and work it out to get each individual answer. So it depends on the type of problem. We're going to do more of this today, and there's a specific process called completing the square, which is the actual process we're going to follow. It is multi-step, but it is pretty easy. So our steps are written here in a list. They want us to rewrite our equation. It has ax plus bx equals c. Notice that the c is after the equal sign. So only stuff with x's should be on the left side. Step 2 is you're going to divide both sides by a. So it becomes x squared plus bx plus c. So the goal for this is to have a 1x squared. You cannot go on until x squared is only down to 1. Can't have any other number in front. That's why we divide everything by a. And then for step 3, this is the actual new part that we're going to be doing. And I will be demonstrating this when we get to the problems And the rest is going to be just factoring and working out the problem like we did above. So let's get into what is actually happening here. So for number 3 and 4, we're asked to solve each quadratic equation by completing the square. So step 1 says rewrite the equation in ax squared plus bx plus c. So what we have here is we have our a, x squared, we have our bx, our c is inside the equation. And we need to have it in the form where it's ax squared plus bx, and then we have the c outside after the equal sign. So I'll do that by subtracting 56 from both sides. When I do that, my equation is now x squared minus 18x equals negative 56. So I have the x's on the left side and I have my constant on the right side. That's what I wanted. Step 2 is to check to see if x squared has a coefficient of 1. And we already have 1x squared right here. So I don't have to do step 2, which is dividing everything. It's already 1x squared. Step 3 now, here's the trick. Now, it talks about a, b, and c. Just so you know, a is the number of x squares you have, b is the number of x's you have, and c is the constant that you have that has no variable with it. What we need to do for step 3, it says complete the square, and read from the notes above, to complete the square by taking half of b, so we're going to get our b value, we're going to cut it in half, and then we're going to square it. That is what step 3 is talking about. So let me go ahead and just kind of make a little space over here to do some work. So I'm going to take our b value. Our b value is negative 18. So I'm going to take negative 18, I'm going to cut it in half, and then I'm going to square it. So listen to me while I talk this out. Negative 18 cut in half is a negative 9. Negative 9 squared, or in other words, negative 9 times negative 9, is a positive 81. So I'm going to use that number, and what it says to do is I'm going to add this number to both sides of my equation. So I'm going to add an 81 on the left side of my equal sign of the equation, and on the right side of my equal sign to the equation. So now what I have on the left side is my 1x squared minus 18x plus 81. On the right side, I have negative 56 plus 81, which is 25. So now it looks like the problem we had above. I need to go ahead and factor this equation on the left. So I know to get the x squared, I'm going to have x times x. I need two numbers that multiply to give me a positive 81, but add to give me a negative 18. And that would be negative 9 and negative 9. So what I have is a perfect square. I have x minus 9 times itself equals 25. Now I'm going to go ahead and start solving for x. To do that, I'm going to square root the left side, square root the right side, and I'm left with x minus 9 equals 25. Excuse me, the square root of 25, which is not going to have a 2 in it. The square root of 25 is going to be positive and negative 5. So now I have to do two equations. I'm going to have to solve when x minus 9 equals positive 25, and when x minus 9 equals negative 25. So I'm going to add 9 to both sides. Plus 9, plus 9, plus 9. And I end up with x equals 25 plus 9, which is 34, I believe. Let's see. It's supposed to be 5 right here and 5 right here. So let me go ahead and rework all that again. I totally messed all that up. I don't know why I went back to the 25. I'm just obsessed with that square root, I guess. I don't know. Yeah, so what I'm going to do is solve x minus 9 equals positive 5, and x minus 9 equals negative 5. It's still there. So now I add 9 to both sides, on the left and on the right. And then x equals 14 on the left side, and x equals negative 4 on the right side. So my solutions, I want x equals negative, actually x equals positive 4, because that just made it get less, not negative. Positive 4 and positive 14. That's kind of a crummy example. I'm not the most happy with it, so hopefully the next one will be a little clearer. So let's try this again. From the beginning, a little more step by step. So, my equation It's already in ax squared plus bx equals c form. My constant's already over here on the left side, which is good. However, in order to go to next step 2, I can't have 2x squared. So in order to get rid of the 2 from in front of the x squared, I'm going to divide everything by my a value, which is 2. I'm doing this because I want to have only a single x squared left over. So when I cut everything in half, I get half of negative 16x is 8x, half of negative 30 is negative 15. Now I have it in the form that I need. So I'm going to have to take my b value, I'm going to have to divide it by 2, and then I'm going to have to square it. My b value is this negative 8 right here. So I'm going to take negative 8, I'm going to cut it in half, that's negative 4. Negative 4 times negative 4 is a positive 16. So positive 16 is going to be what I add to the left side of my equation and to the right side of my equation. When I do that, the new equation I get is x squared minus 8x still, with a plus 16 on the left. Negative 15 plus 16 is going to be just a positive 1. Now I need to go ahead and factor the left side. To get the x squared, I know I'm going to have x times x. What two numbers multiply to give you positive 16, but add to give you a negative 8? That would be negative 4. So what I have is x minus 4 times itself equals positive 1. I need to solve for x. Solve square root the left side and the right side to get rid of that exponent. And I'm left with x minus 4 equals, what's the square root of 1? Positive and negative 1. So now I have to do my two equations. I'm going to have to solve x minus 4 equals positive 1 and x minus 4 equals negative 1. Both require me adding 4 to both sides. I get x equals 1 plus 4, which is 5 on the left side. And I get x equals negative 1 plus 4, which is 3 on the right side. So my solutions are x equals positive 3 and positive 5. If I graphed it, those are the two spots where my graph would intersect the x-axis. Let's continue on the back with some more examples. Number 5. We have 4x squared minus 8x equals negative 3. It's in the ax squared plus bx equals c form, so step 1 is done, but step 2 is not done. I can't have 4x squared. In order to get rid of the 4x squared, I will divide everything by my a value, which is 4. So what I end up with is 1x squared, because 4 divided by 4 is 1, minus 8 divided by 4 is 2x, equals, and I'll just go ahead and leave this as a fraction, because fractions are our friends. Now I'm going to go ahead and take our b value, I'm going to cut it in half, and then I'm going to square it. And b value is negative 2. So I'm going to take negative 2, cut it in half, that's a negative 1. Negative 1 times itself, negative 1 times negative 1 is a positive 1. So I'm going to end up adding 1 to both sides of my equation to make it a perfect trinomial expression. When I do that, on the left side, I end up with x squared minus 2x plus 1. On the right side, I had negative 3/4, which is like negative 75 cents, plus $1. That leaves me with a negative 1/4 or 1/4 left over. Make sure you use your calculator for that. Let's go ahead and factor this left side. I need two numbers that multiply to give me x squared. That would be x times x. I need two numbers that multiply to give me a positive 1, but add up to a negative 2. That would be negative 1 and negative 1. So what I have then is basically the factor of x minus 1 times itself equals negative 1/4. Now it's just repeating the process we did in the previous problems. Also, the square root, the left and the right side. So I end up with x minus 1 equals the square root of, and my bad, I don't know where I got negative 1/4 from. It's supposed to be positive 1/4 because I was adding 1 over here. So that's positive 1/4. That's positive 1/4. It's supposed to be adding 1. So there we go, that makes more sense. The square root of 1/4, if you use your calculator, you'll see is 1/2. So now I have to do find my two solutions. I got to do x minus 1 equals positive 1/2, and x minus 1 equals negative 1/2. The solution to both requires me to add 1 to my answers. So when I do that, I get x equals 1/2 plus 1, which is 3/2 or 1.5. And then over here on this side, negative 1/2 plus 1 equals, I believe it's going to be 1/2, negative 1/2. Yeah, negative 50 cents plus $1 gives you 50 cents, 1/2. So my solutions are at 1/2, comma, 3/2. Leaving things in fractions makes life a lot easier usually. Moving on to number 6. Now this one requires an extra step. First of all, I noticed that the C value is not isolated on the other side. So I'll first remove it by subtracting it from both sides. Oops. Erase that scratch I made. So subtract 8 from the left, subtract 8 from the right. When I do that, I get 3x squared plus 10x equals negative 8. And I think okay, so far, I'm almost on the right track. Now to get the x squared by itself, I'll divide everything by 3. So 3 divided by 3 gives me the 1x squared. I'm going to go ahead and leave 10/3 as a fraction. And then I'll leave even the negative 8/3 as a fraction. Your calculators can handle this, so don't panic. So now I need to do the b divided by 2 squared. Well, b is 10/3. 10/3 divided by 2. 10/3 divided by 2. So in order to do that, 10/3, oops, 10/3 divided by 2 means I'm multiplying times the reciprocal. That gives me 20/3. I'm going to square that. And when I square, let's see, 20/3, which is getting kind of messy here. I feel like I did something wrong. It was 10/3 cut in half. All right, so that gives me 20/3. And then 20/3 needs to revert into another number, which I can't figure out right now. Let's see, 20 times 20 is going to be 400 over 9, which I know simplifies, I believe, to 5/3. I'm not sure about number 6. I have an issue with my notes here. I'm looking at it, and it's all good to here. And then what they did is they took the 10/3, they cut it in half. Okay, I see. They cut it in half this way, multiplying it times half. So you get 10/6, which simplifies, okay, to 5/3. 5/3, when you square that, I get it now, will give you 25/9. So we can kind of go ahead and ignore what I did up there. Just take your 10/3 to divide it by 2. It's the same thing as multiplying it times a half. So that's why you handle fractions in this problem. And then we multiply top and the bottom, simplify, and then we square the top and the bottom. So what I'm going to be doing is I'm going to be adding 25/9, it looks like, to the left side, yuck, plus the right side. The good news is your calculator can handle this math and keep it in fraction form. So when you finally work it out, what you end up with is x squared plus 10/3 x plus 25/9 equals negative 8/3 plus 25/9. That is a really ugly, dirty fraction. I can go ahead and I'm going to give you the factor form. I think personally I'm going to leave out any problems that are just like this, because number 6 is a little ugly with these numbers. And considering we're just learning this, I have a bit of an issue, but I'll go ahead and follow it out. When it is factored, you get x plus 5/3 squared equals 19. Yeah, that's kind of hard to get manually, I'm not going to lie to you guys. So I'm going to go ahead and just stop this problem for number 6 here and leave it at this. This is one that I would not give you. It's a very high level one, and considering we're just learning this, I really am not that comfortable with it. So I'm going to skip it and go on to the other ones to see, well, just to finish working them out, because they are a little more manageable, I must say. So I'm going to skip number 6 and go on to number 7, 8, 9, 10. I am running out of time, it looks like, so let me cut the video short here and begin a second one. So please stop And make sure you upload the next video to continue on with these notes.